hello once again, my dear STEM students. So for today, we'll be discussing all about gas stoichiometry. Okay? So in gas stoichiometry, we have the stoichiometry of gases or the volume-volume stoichiometry calculation involving gases. So for reactants and products that are in the gaseous form, the stoichiometric coefficients in the balance equation indicates the volume and the volume ratio. So in our first lesson with regards to stoichiometry, you already know the molar amounts. So you are now familiar with these two terms, the molar amounts and the mole ratio. But this time, since we're dealing with gas stoichiometry, mag-a-add tayo ng another, which is the volume. Okay, and the volume ratio. Okay, so same thing lang din naman yan. So nagkakaroon lang ng kaibahan yan in terms of the units. Okay, so consider the reaction of carbon monoxide reacting with oxygen-producing carbon dioxide gas. This is the balance equation. So how to interpret this or read this balanced chemical equation? We read this as for every 2 moles of carbon monoxide reacts with 1 mole of oxygen gas, it will produce 2 moles of carbon dioxide gas. So on the other hand, you can also interpret this or name this equation as, in terms of molecules, as 2 molecules of carbon monoxide reacts with 1 molecule of oxygen gas to produce 2 molecules of carbon dioxide gas. But in terms of our lesson for today, since we're dealing with stoichiometric calculation involving gases, we will be using the volumes. Okay, so this is another way of interpreting this equation. So you will name this or interpret this as for every 2 liters of carbon monoxide reacts with 1 liter of oxygen gas, it will produce 2 liters of carbon dioxide gas. This is another way of interpreting this balanced chemical equation in terms of volume ratio. Okay, so for our first example, in the complete combustion of propanes with chemical formula C3H8, a gas that is in LPG tanks and used as fuel for cooking food, the balanced chemical equation is for every 1 mole of propane reacts with 5 moles of oxygen gas to produce 3 moles of carbon dioxide and 4 moles of water vapor. So this is yung dati nating interpretation na ginagawa in terms of the giving the name. But this time, since we are dealing with stoichiometric calculation of gases, we'll be using the unit of volume in interpreting this equation. So these are the interpretation: 1 liter of propane, 5 liters of oxygen gas, 3 liters of carbon dioxide, and 4 liters of water vapor. Okay, so assuming all volume readings are made at the same temperature and pressure, okay, what will be the volume in liter of oxygen required for the complete combustion of 0.350 liters of propane? And what will be the volume of carbon dioxide produced from 0.350 liters of propane also? So in our for letter A, first required. So what will be the volume in liters of oxygen? So given the balance equation of the complete combustion of methane, okay, so given value times the volume ratio of oxygen gas and propane from the balance equation, kaya siya yung naka-pink. So ito lang ang gagamitin natin, itong dalawang substances na to in the reactant, in computing for the volume stoichiometric calculation. So our starting amount or the given value is 0.350 liters of propane. So you multiply it by the volume ratio of the two. Okay, so that is 1:5. For every 5 liters of oxygen gas, there is 1 liter of propane. And then cancel the units of liters to get 1.75 liters of oxygen gas. Okay, so volume. Nag-start kayo sa liter, nag-end kayo sa unit ng liter. Kaya volume, stoichiometric calculation. Okay, for our next, so what will be the volume of carbon dioxide produced from the from 3.0350 liters of propane. Okay, same equation, same computation map, and then same dimensional analysis. Okay, we'll multiply it dun sa mole ratios of the unknown and the given. Then cancel the units of liter. Then you will get 1.05 liters of carbon dioxide. This is how you compute for the volume stoichiometric uh, gas problem. So let us proceed to the volume mass gas stoichiometry at standard condition. When we say standard condition, in this particular mathematical stoichiometric problem, rather, it involves the standard condition at STP, or the standard temperature pressure, or the standard condition in terms of the number of moles, the volume of the substances, etc. Okay? So calcium carbonate. So for our next example, calcium carbonate, also known as limestone, is decomposed to produce calcium oxide or lime, an industrial chemical used for glass manufacture or for sewage treatment. So carbon dioxide is also produced during the reaction. So this is the balanced equation during the decomposition reaction of calcium carbonate. Okay? So calcium carbonate. Calcium carbonate, solid calcium carbonate, 1 mole of solid calcium carbonate decomposed by heat to produce 1 mole of calcium oxide and 1 mole of carbon dioxide gas. That is the interpretation. So how many grams of calcium carbonate must be decomposed to produce 5.0 liters of carbon dioxide gas at STP, or the standard condition. So at standard condition, for every 1 mole of any substance at STP, the equivalent volume is 22.4 liters of gas. That is for every 1 mole of gas is equivalent to 22.4 liters of gas. Excuse me. Okay, so how many grams of calcium carbonate must be decomposed to produce 5.0 liters of carbon dioxide at STP? So this is our balance equation. So ang kailangan lang natin is the carbon dioxide substance and the calcium carbonate. So for our computation map, this is our dimensional analysis in words. Okay, so for the given volume, which is 5.0 liters, you will multiply that to the standard molar volume at STP times the stoichiometric coefficient and then times the molar mass ratio of the required. If you're going to analyze this, you will start with volume and then you will end up with mass. So ang answer nyo dapat dyan is in grams. Okay? So next, so volume of carbon dioxide. Okay, in some books, ganito yung representation nila. So, volume of carbon dioxide and will give you the moles of carbon dioxide. Okay, so after computing for the standard molar volume, ang matitira dyan is the moles of carbon dioxide and then followed by the moles of calcium carbonate. So, after computing for the stoichiometric coefficients, then it will lead you to the molar mass ratio and then the molar mass in grams. Okay, so our starting amount for our dimensional analysis is 5.0 liters carbon dioxide multiplied by the standard molar volume. Gagamitin nyo na kagad yung parang conversion factor ng for every 1 mole of gas that is equivalent to 22.4 liters since we need to cancel the unit of liters in our given starting amount. So ilalagay nyo na siya dyan. So for every 1 mole of carbon dioxide, there is 22.4 liters of carbon dioxide. And then cancel the unit of liter. Then you will get the moles of carbon dioxide. Kung mag-i-stop yung dimensional analysis nyo dito. Pero magpo-proceed pa kayo sa next step, which is the stoichiometric coefficients. So, lalagay niyo natin. So, for every 1 mole of calcium carbonate, there is also 1 mole of carbon dioxide. And then cancel. May the moles. So, ang matitira dyan, kung dyan na may stop ang inyong dimensional analysis, ang matitira niyong sagot is the moles of calcium carbonate. Pero hindi pa rin dyan, so magpuproceed pa tayo sa isa pang step. Okay, so you calculate the molar mass ratio of the required substance. So for every 1 mole of calcium carbonate, there is 100 grams calcium carbonate, and that is the molar mass of calcium carbonate. Then cancel mole of calcium carbonate, and then you will get the end unit of grams. And then perform the mathematical operation. Okay, so the answer is 22.3 grams of calcium carbonate. Since we have three significant figures in your starting amount, 5.00 has three significant figures, so your final answer must be 23.3 grams of calcium carbonate with three significant figures also. Okay, so the next example is for gas stoichiometry and the ideal gas equation. But this time, this is not in the standard condition. So wala kayong makikitang STP doon sa mathematical problem. So tungsten, a metal that is used in light bulb filament, is produced industrially by the reaction of tungsten oxide and hydrogen gas based on the balanced equation. So this is the balanced equation for the production of tungsten in tungsten oxide reacts with hydrogen. So if you're going to interpret this chemical equation, for every 1 mole of tungsten oxide reacts with 3 moles of hydrogen gas, it will produce solid tungsten and 3 moles of liquid water. So how many liters of hydrogen gas at 35 degrees Celsius and 745 millimeters of mercury are needed to react completely with 875 grams of tungsten oxide? This time, meron na kayo nakikitang ibang mga numerical value. This time, meron na kayong temperature. Meron din kayong unit of pressure. This is another unit of pressure aside from atmospheric pressure. The atmospheric pressure is the unit used at standard condition. But this time, this is not in the standard condition. So, nakalagay muna siya sa millimeter of mercury. Okay, so for our given, we have our balanced equation. So the mass of the reactant, which is 875 grams of tungsten oxide. So ito yon. So yung 875 grams of tungsten oxide. So the condition of the gaseous reactant. So what is the gaseous reactant? Our gaseous reactant is carbon, the hydrogen gas. Okay. So that is the the gaseous reactant. So the pressure being exerted by that particular gas is 745 millimeters of mercury. So since we are dealing with the ideal gas equation this time, so the temperature is in degrees Celsius. You have to convert that to the the Kelvin scale by adding 273. So you will get the final temperature reading at Kelvin, which is 308 degrees Kelvin. So for our unknown, the volume of hydrogen gas at non-standard condition. Okay, so how many liters of hydrogen gas at 35 degrees Celsius and 745 millimeters of mercury are needed to completely react completely with 875 grams of tungsten oxide? So this is our balanced equation. So we need to find all gas variables in the ideal gas equation. Kasi we'll be using the ideal gas equation, kailangan meron tayo lahat. Okay? So we need to have the pressure, volume, the number of moles, the universal gas constant, and then the temperature. Bago natin magamit tong equation na to. So for our step 1, we have to calculate the number of moles. But this time, you will use the mass mole stoichiometry. So you are now familiar with the mass mole stoichiometry kasi ito yung lesson natin na nauna. Okay? So, so in our given, so meron na tayong grams. Okay, ito yon, yung 875 grams of tungsten oxide. So that will be your starting amount in computing for the number of moles. Okay, so starting amount natin is in grams. So ang next dyan is the molar mass ratio. Okay, cancel yung grams. And then next is the stoichiometric coefficients. So for every 3 moles of hydrogen gas, this is based on the balanced equation. For every 3 moles of hydrogen gas, there's 1 mole of tungsten oxide. So cancel the mole of tungsten oxide, and then you will get the number of moles of 11.3 moles hydrogen gas. So meron na agad kayong N sa PBNRT. Okay, so na-compute nyo na si N. Okay, meron na kayo nito. Okay, next step. So the unit of pressure in PVNRT is at ATM, so we need to convert millimeters of mercury to atmospheric pressure by using the conversion factor. For every 1 ATM, there is 760 millimeters of mercury. You have to convert that. So our starting amount is 745. This is the given pressure. Okay, asan na siya? So 745. Okay, this is 745. And multiply it by the conversion factor. So yung unit label natin is for every 1 ATM, there is 760 millimeters of mercury. Cancel the unit of millimeters of mercury and you will get 0.980 atmospheric pressure. So meron na kayong pressure sa PBNRT. Okay? Next. Then calculate the volume of hydrogen gas using the ideal gas equation. This time you can now calculate for the volume using PV and RT. So for our step 1, we have the number of moles, which is 11.3 moles of hydrogen gas. And then for step 2, we have 0.980 atmospheric pressure. So this is our equation. Our unknown is volume. So kung ano yung tabi ng unknown, so that will be your denominator. Okay, and then substitute all given values. So for our number of moles, that is 11.3 moles of hydrogen gas multiplied by the universal gas constant. So ito yon. And then your R. Okay, so 0.0821 liter atmosphere per mole Kelvin times the temperature, which is 308 degrees Kelvin all over the amount of pressure, computed amount of pressure, which is 0.980 atm, and then cancel all unwanted units. Okay? And what is left is the unit of volume. Kasi ang kailangan natin, calculate the volume of hydrogen gas. So you can now calculate for the volume. Okay, so perform the mathematical operation in the numerator. So if you multiply all those values, you will get 286 liters divided by 0.980, and then you will get the total volume of hydrogen gas, which is 292 liters of hydrogen gas. Okay, this is how you compute for the volume of gas in the non-standard condition using the ideal gas equation. So if you have any question, you may leave your question in our Google Classroom or in our group chat. So stay safe, stay healthy. God bless everybody. Thank you.